the magnitude of electrostatic force between two point charges is directly proportional to the product of magnitude of two charges and inversely proportionality to the square of distance between the two charges and force acted along line joining the two charges. So this is the statement. Okay, so this is the statement is I think maybe lengthy. Don't it is complicated. It is a very simple statement. So but it is in the sentence form. It is appear like a lengthy. But according to the equation, keep it in your mind very simply way. The magnitude of electrostatic force. The magnitude of electrostatic force between the two charges is directly proportionality to the product of magnitude of two charges. Product of magnitude of two charges. The magnitude of electrostatic force between the two point charges is directly proportionality to the product of magnitude of two charges and inversely proportionality to the square of distance between the two charges. So what is the distance between these two charges? R. Square of the distance between the two charges. So this is the statement of Coulombs law or electrostatic force between the two charges. So comparing these two equations, that is the electrostatic force is directly proportionality to the product of the magnitude of the two charges and inversely proportionality to the square of the distance between the two charges, and the force is acted upon line joining the two charges. So this is the line joining these two charges. This is the force. So remove this proportionality sign. So remove the proportionality sign. That is, introduce the new term. The new term is called as K. So K is called as proportionality constant. Okay, or K is called as proportionality constant or Coulombs K is depends on the which factors? The K is depends on the K is depends upon first unit. Depends on the unit. Second one depends on the medium. So let's talk one by one. First is depends on unit. So there are two important units, that is in CGS system and SI system. So in the first one, in CGS system, what about the K value? So in CGS system, first one is I focusing unit. In CGS system, the K value is equal to 1. Okay, so K value is 1 means the equation becomes, the electrostatic force equation becomes is equal to magnitude of K1 K2 divided by R square. So in the CGS system. In SI system, K is equal to, okay, in SI system K is equal to what? 1 divided by 4 pi epsilon naught. Okay, so where epsilon naught is called as electric permittivity of free space. Electric permittivity of free space. So that's value epsilon naught in electric permittivity of free space value is 8.852 into 10 to the power of minus 12. So that is equal to 8.854 into 10 to the power of minus 12. So let's check the unit. How to check the unit? Let's K is equal to, okay, what is the unit? In SI system, okay, I am focusing SI system. F is equal to magnitude of S is equal to K. Instead of K, I put to 1 by 4 pi epsilon naught Q1 Q2 by R square. So epsilon naught, it is shifted to the this point. Epsilon naught, and this one is K. Sorry, F. So now this becomes constant. Okay. Charge. So SI unit of electric charge is Coulomb. So Coulomb, that is equal to Coulomb square divided by, it is F. F is a Newton. Then R square, it is meter square. The unit of electric permittivity of free space, unit is Coulomb square per Newton per meter square. This is the value of epsilon naught. Okay, so it is the depends on what when it is finished. Then it is a depends on the medium. So let's come to the point, medium. So medium, for example, in air medium. In the air medium, in air or vacuum, okay, now for air, so in free space or vacuum, thus K is equal to, it is very, okay, very. How it is very? So let's discussion in the next, that is a next concept. Okay, so that K is depends on the two factors. It depends on the unit and it depends on the medium. Okay, then, so what is the 1 by 4 pi epsilon naught value? So let's take this value, that is equal to 1 divided by 4 into, so 9 pi value is 3.142 into epsilon naught value is 8.852 into 10 to the power of minus 12. So now simplified, that's value is 9 into 10 to the power of 9. So this is the value. The unit is what? Unit is, so for example, this is the K. So K, that is equal to K Q1 Q2 divided by R square. I want to K is equal to F R square Q1 Q2. So F Newton meter square per Coulomb square. So the unit is what? So the unit of this value is 9 into 10 to the power of 9 Newton meter square per Coulomb square. So that is the K value in case of free space. Okay, so these are the important values for in the solving of the numericals. Okay, so this is the what? Coulomb's law. So but the Coulomb's law still it is not completed. So it is not completed. So it is a some extended Coulomb's law is there. So I am focusing only for the magnitude. Okay, so these are the magnitude values. I am not focusing about the direction, but in the Coulomb's law, the most preferable is direction is the most important. So in case of the like charges are repulsive force, unlike charges are attractive. So I take this is a positive charge and positive charge. So these two charges are repulsive force. So the force is exerted. The force is exerted second charge due to the first one. The force is exerted first charge due to the second one. Okay, so let's talk the force exerted from the second charge due to the first one. The force is exerted first due to the second one. Coulomb's law in vector form. So it is for more importance. So why the Coulomb's law? It is in vector form because you know very well vector. Vector means magnitude and directions. So let's take the two charges in the 3 axis. So this is x axis, y axis and z axis. So let's consider the two position vectors are most important. The charge Q1 is placed with the position vector R1 vector. Another charge Q2 is placed with the position from the origin R2 vector. The two charges are placed in the 3 axis because this is a how to representation in the vector form. That is the reason I kept the charges in the x, y and z axis. So let's consider the position vectors R1 and R2 of the charges Q1 and Q2. So what is the force exerted on the Q2 charge? So from the single charge, does any force is exerted? No, it is the another charge is required. So what about the another charge is there on that one's situation? That is another charge is Q1. So the force is exerted on Q2 because of due to the Q1. So this is like that. The force is exerted on Q1. So because of due to the charge, which one? Because of due to the Q2 charge. So that means the force is exerted on Q1 because of Q2. The force is exerted on Q1 because of due to the charge Q2. The force is exerted on Q2 due to the charge Q1. The distance between these two charges are 2, 1 vector. So let's consider position vectors R12 vector and R2 vector due to locate take the charges Q1 and Q2. So the distance between these two charges R2 vector is the distance between the two charges. So the force exerted on Q2, the force exerted on Q2 due to Q1. So the force exerted on Q2 due to Q1 is R21 is equal to K is a Coulombs constant or electrostatic force constant, magnitude of Q1, Q2 divided by, so distance is how much? R21 vector square mod. Okay. So this is the force exerted Q2 because of due to the Q1. Now, so what is the direction? Let's you have to focusing on the direction is most important because the how to Coulombs law is deriving in vector form. So in case of direction, the unit vector is most important. So the unit vector is R21 cap is a unit vector. So R21 R21 cap is a unit vector. It is along in the direction of the force. So this is the what R21 cap. It is along the direction of force. So in this direction, that is a R12 cap. It is along the direction of force. So you know when unit vector already defined in the first year motion in a plane topic. So that is a R21 is equal to the magnitude. Nothing is there means it is magnitude. I take directly. The vector of the unit vector divided by what? Magnitude. So instead of this, okay, this means this is a along the direction is most important. Along the direction of the force. So that F21 vector is equal to mod is equal to K mod Q1 Q2. Okay, I remove the mod. Okay, why I remove the mod? So it is a what? So this is only the magnitude. Okay, it is only for magnitude. So this is only magnitude divided by R21 vector square into R21 cap. So that is R21 is a unit vector along the direction of force. Along the direction of force. Okay, I cannot forget the mod. So this is the mod is I removed. Why I removed the mod? Because this is a R21 cap is a specified that direction of along the force. It is the direction. Okay. This is I remove the mod. Why? So this is a positive charge. This is a positive charge. Positive charge plus plus. So plus plus, the product of the plus plus becomes plus. Minus minus, the product of the two minus minus sign becomes positive. Then if in case of one is positive, another one is negative. So let's take one is a positive, another one is a negative. At this case, the final result is what? So this is a what? The unlike charges of attractive force. Attractive force. It does not impact on the unit vector. The location of the charges remains same. So remains unchanged. Then it does not impact on the unit vector. So the unit vector direction is same. The unit vector direction is same. So this force, the force is exerted on charge Q2 because of due to the Q1. The force exerted on 1 due to the charge 2. So at this case, that is a F21 vector is equal to K Q1. One is positive. Positive Q1. Another one is negative Q2 divided by separation is R21 vector square, then R21 cap. It is a opposite to the direction of force. The opposite to the direction of direction is shows with the negative sign. Look at this one. So this is the F21 force is this direction. This is a opposite. That is minus R21 cap. So minus into minus plus, again I got positive value. That is the reason I ignored the part of magnitude. So instead of this one I put, or it is the same equation, R21 vector is equal to K into Q1 Q2 divided by R21 cap. R21 cap means R21 vector divided by R21 cube. Okay, so this is the equation of Coulombs law in vector form. So in case of position vectors, okay, so in case of position vector, the same equation is, so in case of position vector, in case of position vectors, so according to the triangle law, so the position of R2 due to the R1, it is R21 vector. So R21 vector means the position of 2 with respect to the position of 1. So the position of 2 with respect to the position of 1 means this is a R2 according to the triangle law. What is the position? Okay, R21 is the position of 2 with respect to the position of 1. So what is the position of 2 according to the triangle law? So what is the position of 2 according to the triangle law? The position of 2 is equal to R1 plus vector plus R21 vector. So I want to R21 value. So R21 becomes R21 becomes in this equation, R21 becomes R21 vector is equal to R2 vector minus R1 vector. So put in equation number 1, any one. Okay, so put in equation number 1. Put in equation number 1. Equation number 1 becomes F21 vector is equal to K Q1 Q2 K Q1 Q2 divided by R21 cube. This is R21 vector means R2 vector minus R1 vector. This is in case of the position vector. So now still only I am focusing F21. The force is exerted on Q2 because of due to the charge Q1. So now I shifted to the force on Q1 because of due to the charge Q2. Okay, the same equation. So nothing is changes, only what you have to shift it. This is a R21 becomes R12. This is F12. Yeah, R21. R1 minus R2. So like that, you have to come to the point. The force exerted, the force on charge Q1 due to the charge Q2. The force exerted on Q1 due to Q2. The force on charge Q1 because of due to the charge Q2, that is equal to K Q1 Q2 divided by so the distance is R12, this is R12 cap. R12 cap is called as unit vector along the direction of the force F12. Look at the diagram. Okay, the clear picture is there on the figure. Okay, we know the last equation is the force exerted on charge Q2 because of due to the charge 1 vector is equal to so that is K Q1 Q2 divided by R21 square. It is a R square means R12 square R21 cap. Okay, so this is called as equation number 1. This is equation number 2. So but we know that, okay, so but we know that, but in the figure R12 vector is equal to minus R21 vector. Okay, so the clear picture is there. So and also R12 is equal to minus, that is a R21 minus. So this is the what the conclusion part from this one is equal to F12 vector is equal to K Q1 Q2 divided by this is R21 square R21 cap with minus sign. So that F12 vector is equal to K Q1 Q2 R21 square R21. So this minus is shifted. So this becomes this K Q1 Q2 R21 square R21 cap. This is minus is as it is F21. So this is the what? So the Coulombs law in vector form, it is obey for what? So it is the obey the Newton's third law of motion. Newton's third law of motion. So what is the physical significance of Newton's third law of motion? This one. So let's see what is the physical significance. You have to take the charge Q1. From the single charge cannot produce the what? Electrostatic or Coulombs force. You want to another charge. So you have to another charge. I brought into small distance, that is the distance is R12 distance. I kept the another charge, that is plus Q2. Okay, so then how much force is exerted from the Q1 charge? So how much force is exerted from the Q1 charge due to the Q2? The same amount of force is exerted on Q2 because of due to the Q1. So So this is the what? Newton's third law, but in opposite direction. So this is the direction is this. So this direction is this. So this is part of the Newton's third law of motion. So one more important point. So if the charge, the product of the charge is, if the product of the charge is greater than 0 or lesser than 0, so how to draw the figure, how to representation with the diagram. Okay, so if the charge Q1, Q2, if the product of Q1, Q2 greater than to the 0. So the product of the Q1, Q2 charges is greater than to the 0 means, so this is also what? Positive, positive. Or negative Q1, negative. So this is possible, this is possible. So one is negative, another one is positive means the final result is minus. So minus is not greater than to 0, this case is not possible. So only two possibilities are there. The first one, both the charges are like charges. So both the charges are like charges means this is a Q1, this is the another charge is Q2. So with the certain distance R12, so both the like charges, it is a repulsive force. So this is the force exerted 1 due to the 2, the force exerted on 2 due to the 1. Then second one. So Q1, Q2 is lesser than 0. So it is opposite to the first case. So opposite to the first case means the one is positive charge, the another one is negative charge. So this is the plus Q1, this is minus Q2 are placed in certain distance. Or 1, 2. It is vector. The force is exerted from Q1 because of due to the Q2. The force is exerted from second one due to the first one charge. So this is the what the figures are representations for Q1, Q2 greater than 0 or lesser than 0. The conclusion part is from the Coulombs law in vector form. Okay, so let's see the next class.